So this presentation is really all about combining the Mastercam lathe license with a mill license. And there's a lot of questions about that come in from customers and end users. And so we're going to talk about that and what some of the benefits are of combining the mill and the lathe license together to sort of expand what you can do with Mastercam lathe. So we're going to kind of talk a little bit about some of the terms, and we'll also try to distinguish the difference between different types of programming, either using Mastercam with a traditional MP post versus the mill-turned dot machine environment. We can talk a little bit about the stock setup page and axis combinations, and then we'll go into planes for milling, talk a little bit about pick-off cutoff, and setting your subspindle position, Z position, or an order of operations, and managing posted code. May touch on that if there's time. So I guess we'll just move on into it here. So so before we get started, it's good to have a good understanding of Mastercam lathe and the mill product. Obviously, when you put these two together, it would be a little more challenging if you just knew Mastercam lathe, hadn't worked in mill, and then you couple those licenses, and then you're not familiar with the milling tool path. So try to get a good understanding of both sides of Mastercam first, and then also experience in the current version. So for example, if you have a lathe license and you're using 2023, but you haven't touched mill since 2019, that could be a little bit of a challenge also. So it's good to kind of get your basic learning out of the way first for the fundamentals of those two licenses, and then working in the same version. When you first start off with this, getting a good understanding of your CNC machine first, we do see customers that sometimes get the cart before the horse. They're anxious to get programming, but they're not so familiar necessarily with the machine itself. So getting through your training on your machine and getting a good understanding of the code and everything for the machine, so you know what to expect from the output. Anything to add to that, Jeff?
Well, touching on licensing, if you did have like outdated licensing, like you had mentioned for mill in 2019, by being in the current version, you get access to things you may not otherwise have had access to. So something like OptiRough, which you can use while with your lathe parts, used to be only mill 3D for like version 2019. And so in the current version, you only need a normal mill 2D seat, and you'll have access to those toolpaths. And so making sure that, of course, your licensing's up to date, you usually get a few more goodies that you get to have at your disposal. And so that's why we always, recommend being in the current versions.
Yeah, excellent point. That's great. Well, let's take a second here and see if any questions pop up, and encourage the attendees here to use the questions
Yeah, we
panel.
hadn't mentioned that in audio. Let's see. Paul's wondering if everyone's still connecting or if it's just him. I'll let him know to try refreshing the browser. But yeah, feel free to please ask your questions in chat. I do know sometimes people have issues with connections or something like that with Demio. Oftentimes I find to fix those, you can just refresh the browser and the session will pop back up. But if you ask any kind of questions in chat, I'll go ahead and read them and answer them as best I can. If I feel like it's something we can ask in presentation, I'll stop Tim and ask the question live, which is always fun.
There we go. That's always fun. All right, so let's jump into this. So next up is why use a mill license when lathe can do C and Y axis milling. And so I took a couple of screenshots here of the menu structure for milling ops just within the lathe product, which is on the left here. So you'll see that if you're running a lathe only license and you look down through the turning operations and you get down here to C-axis, and you're going to find a face contour, cross contour, C-axis contour, face drill, cross drill, and C-axis drill. So there's a couple of real basic kind of milling operations for C and or Y-axis cross and face built into the lathe product. That does not require a mill license at all. That's some milling, some very simple and kind of legacy milling tool paths that have been coupled with lathe since pretty much the beginning of the lathe product, so that you can get a few things done with a machine with a C or and or Y-axis live tooling lathe. When you combine the two licenses, now you have the ability to pull the full suite of milling tool paths, and that's anything from mill all the way to mill 3D with multi-axis. When you jump from mill 3D into multi-axis, there's some considerations in the development of the MP type post. And again, our focus here is all about Mastercam mill and lathe licenses being used with an MP type post processor. And then we'll talk about the advantages of going to a dot machine environment, which is a completely different type of post-processing system, which has fully incorporated machine simulation and collision detection that's built in. So that's sort of another level up in Mastercam. The good news is that these are all building blocks. So if you have Mastercam lathe and then you add Mastercam mill, those licenses are necessary to get to the full mill turn environment using the dot machine type post processor to get to the simulation. So you need those two building blocks. Then one other piece that you need if you have a dual turret machine and you want to be able to synchronize that and fully simulate it for collision detection, then you need the mill turn license for Mastercam. So that's only required for machines that have two code streams, or say for example, a B-axis head and a lower turret. Then you need to add the mill turn product to the mix also. So this is why we get a lot of questions, because it's kind of layering in the product. So you can work your way up towards the dot machine, and once you see the benefits from a programming standpoint. But if you have an MP type post processor that's built for your machine, and you have the two different licenses, mill and lathe, then you can start doing these kind of more advanced milling type operations. So again, lathe by itself, you have some basic mill operations, but when you launch the two licenses together, all of a sudden you have access to the full mill menu. So those license combinations could be something that stems from having a HASP that has both a mill and a lathe license on it, or a standalone software license that has mill and lathe on it, or a network software license where you're able to pull a mill and a lathe license together. Also, the NetHasp type licensing gives you that same capability to pull those two licenses on a single system together. So, Jeff, do you have anything to add to that?
Sorry, I got distracted by a question that from Tarek about can we get accurate
No worries.
simulation of single spindle machines without a dot machine environment. And I was explaining, not currently, the machine simulation we have within Mastercam is for milling machines. And the engine's different that we use for dot machines. It's its own standalone product. The closest you can get to simulation of some type with an MP post with lathe would be Verify, but then you're missing your tool holders and things like that could be possibly colliding with chuck jaws and spindles.
And we have a good slide that's going to show that very clearly here in just a minute. But in terms of combining the licenses, so you have your settings, say on a network software license to be able to draw or pull those two licenses together. So can you explain that?
So when you're using a network software license, and if you had a just your bare bones Mastercam shortcut on your desktop, when you open up Mastercam, it will attempt to pull in both of your lathe and mill licensing. Now, sometimes companies and organizations don't want to have that happen. They want their programmers to either be in lathe or mill, and so they may have set up how their licensing is handled through the Mastercam launcher to kind of restrict those licenses. You can also use that Mastercam launcher to specifically launch Mastercam checking out the lathe and mill. That way, if you are programming with your lathe part, you're not restricted to just the lathe toolpaths. You'll also get the mill toolpaths along with it. And we actually have a knowledge-based article that kind of goes over how the Mastercam launcher utility works. I'll go ahead and post that in the chat. But that talks about how you can create shortcuts that'll exist on your desktop that will open up, specific licensing. So this had been a problem, I know, for one customer individual where they were used to programming with lathe, but every time they opened it, all they had was lathe, and they could not get their mill to come in. And so we had created a shortcut for them that also launched with their mill product. That way they had access to those mill toolpaths. And then something that happens a little bit differently in Mastercam is that if you've normally selected either lathe or mill, your toolpaths tab is labeled as toolpaths. But when you have both products open, the toolpaths tab is no longer called toolpaths. It's called lathe or milling. And so you'll see that in Mastercam when Tim is programming here, that you have those toolpaths up. And since we're a reseller, we also have the routing tab, which is essentially milling operation,
Right.
So
it can be also combined, interestingly enough.
But the Mastercam launcher utility is a good way to make sure those two licenses are being launched in conjunction with one another.
Right. That's good. So if anybody's struggling with that when they first start off, typically if we're delivering a custom MP type post processor, we're working with the customer to get it set up on their system, and we would already be having this discussion. But for those that are kind of doing it on their own, or maybe they have acquired a post from another source, this is what's required to make that work. So not making any assumptions there as to like, what, why is my milling not showing up? That might be the case, is that license is not accessible or is not being pulled in. So, good reasons for pulling in the additional options, the wide range of milling options, which are really beneficial for mill turn applications. And, we see peel milling as being a pretty big deal for cross operations where your depth of cut is varying because you're going up and over something round. Say you're slotting through something. It's nice to use the peel mill. Typically you have less RPM capabilities, less horsepower, maybe a little less rigidity. And so the peel milling really is the ideal tool path for that. And then to go into something quite advanced, like say you wanted to tap into the full multi-axis deburring, and you have a post MP type post that has that built in for the milling operations for lathe, then you could use the deburring option in multi-axis. So any of the dynamic strategies, the circle milling, using the hole recognition, and chamfering, surface machining, etc. All of those things are not available in just the standard lathe product. So it kind of expands what you can accomplish, when you're trying to do this.
Here, just for some,
so when
I just want to get some clarification. Ryan,
Yeah.
There's some garbled in transmission. He was wondering if he was misunderstanding. Does the machine simulation work in the mill turn environment or only the mill side? So I had misspoke. The Machine
Oh,
simulation inside Mastercam, what we call mock sim or something like that, would be mill machines only, but the mill turn environment, sometimes called a dot machine,
has
that's
its
its
own.
own full
Yeah.
simulator for the lathe environment itself. And so that's a product that lives within like a Code Expert. And
Yeah.
then that's different from MP style posts. You may sometimes hear mill turn simulations called MP.net, and that's that side of the post. So it's a different post language is MP.net versus MP. And so we typically delineate that as mill turn lathe environment, and that is the full simulation for lathes. But that is a separate add-on, and it does require a lathe and a mill license in order to get that for your lathes at a minimum.
And I think to elaborate on that a little bit, Jeff, the thing to understand is that when you buy a machine environment or a dot machine, it is the post processor and the simulator all coupled into one
Yes.
package. So it's very specific to that machine. It has the skins or the machine assembly for that particular machine, make, model. In fact, in many cases, it's customized right down to that particular serial number of machine. And so they're much more expensive, but the benefit is there obviously in collision checking and the ability to fully simulate all your locators and the full turret assembly against the chuck jaws, um, uh, and everything in check for collision. So we got a little kind of animation that's going to play here in a second that's going to kind of show the difference between these two. So we were talking a little bit about the terminology. So when we start to talk about POCO, we're talking about the pick off, cut off. So we say that a lot and assume that everybody knows what POCO means, but that's Mastercam's part handling operation pick off, cut off. We're going to talk about axis combinations a little bit. That's very important when you're working with a machine with two spindles, because you're assigning typically G54 to the origin part origin for the part on the main spindle and G55 on the right or the sub spindle. And so those axis combinations kind of move the coordinate system over to the sub spindle. And so you have to know where that's at, know how to select that to get good output. A lot of people will miss that because they go into the tool path and it defaults to left axis combination and they needed to toggle that to right. Sync codes, sync codes and weight codes all come into play when you get into dual code stream. We have very few installations of MP type posts handling multiple code streams. It can be done sort of blindly in an MP post, but it's nothing like being able to fully synchronize with full simulation. And that is what the dot machine is built for from day one, and its sort of architecture was all based on multiple code streams and not just two. It can actually handle three or more. So for triple turret type machines and whatnot. So a little bit on the difference between the two styles. Now, heads up on that, this little animation will kind of show you. So if you look initially here, you'll see this is what you're going to see in your verify just using an MP post with mill and lathe. And then when you get into dot machine, this is what you're seeing for kind of that same machine and the same program. And so you get the ability to understand collision potential like this, and then to be able to quickly go in and correct that. So you're kind of flying blind a little bit with just verify. You can elaborate more on like the tool mounting or the tool holder for live tooling and get a little bit more accurate display on the stick out of the tool and collision check a little bit here, but it's nothing like seeing the full 3D assembly of the machine in there. So same licensing as far as Mastercam goes for the toolpath generation, but it's an additional license when you buy the dot machine environment that comes with the post and the simulator. and that is a licensed product. So you don't need the mill turn license unless you're doing more than one code stream. If your machine has 2 code streams, then you need the mill turn license as well. There is a presentation on our website that goes into some more detail about lathe versus mill turn. And so, Jeff, I don't know if you want to try to hunt that down. John said it's in the MCAM videos.
Yeah, and
to make mention of that, because it's a pretty lengthy presentation about that, in case anybody wants to
we're
look
not
at
able
that.
to actually link the videos specifically themselves from that page, but in chat is our videos page, mcamnw.com/videos. And, the first presentation in there is building blocks for mill turn. You're also able to kind of scroll down and see other presentations we may have for it, but I believe it's that, right? The building blocks for mill turn that we have there.
I think that's it. Yes.
And that's a, there may be a way to link that directly, but unfortunately I haven't figured out how to link Demio videos or Vimeo's videos. Here, I've got
think
it.
that there's not that many videos on there.
Here,
so.
I got it.
Okay, good.
You just have to try sometimes. Also link in chat to that video.
Well, that's good. They can see kind of the current videos that we have up there on the website, plus a link directly to that one. Okay, so that gives you a good animation to kind of see, if you're doing really basic live tool operations, cross or face, this is going to be fine. It's just when things are tighter, they get, you're very uncertain as to what clearances are. Maybe you have a smaller mill turn, you're working in very close to the chuck, or maybe even a collet system, and you're working very close to the spindle, then it gets pretty iffy, right? Because you have your adjacent tools and those locators, that could also interfere with the chuck jaws. So if that's the scenario and you're doing that on a regular basis, then maybe there's a return on investment for jumping into a dot machine for that particular style of
and
machine.
an anecdote for me, I used to program on just normal MP posts where all you had was verify, and I would find all the times I'd run out to my machine and realize I had a tool in a station that was too close, and I all of a sudden needed to move it to the back side of the turret or something like that. And it facilitated running into the back into the programming room and, changing that up. And so making adjustments, and having that simulation and being able to run it at the computer itself really highlights those collision issues before you're out there kind of loading tools into the machine. Great visual check for that. Of course, full collision checking, which is the big important one. But dot machines are my personal favorite. You can still program in the normal MP posts. You just have to be a little bit more cognizant of where your tools are at on the turret.
Right. So it really took the development of the dot machine environment to be able to feed it enough information through the post processor and then off into simulation. That's why that's all packaged together to get that accurate display. So yeah, it's a whole different world once you get into that environment. So Jeff, if you get a chance, you might load that file and just kind of have that queued up on your system. So there is a mill turn example in there, and at the tail end when we get into the Q&A section, if anybody wants to look at that, we can pull that up and show it. Okay, so moving on, we're going to talk about the stock setup page. So I'm going to jump into that. So I've got an example that's programmed up here, and I have some view sheets that are set here. We're going to talk about that. And so the structure for this is all done with an MP post. And I have my POCO ops and subspindle ops, and then my main spindle operations. And then in the setup for this, in stock setup, I have my left spindle stock defined just as you would for lathe. I have my left chuck jaws defined. just as you would for standard lathe programming. But then you'll also notice I have a right spindle defined here. And when I go to properties for this, I have a distance set in here, which is the distance between or for where that chuck location is at. Now, I'm just using an arbitrary value of 15 inches. Of course, that would be a very, very small lathe, but this is just really visual. So you're on screen in Mastercam when you're not running a machine environment. It's just sort of symbolic distance between the main and the sub spindle. You want that number to be pretty realistic for whatever machine you're programming. And so you do need to set that distance there. Once you set that distance, then when you go to do your POCO, you're going to see things transfer from, from your main spindle to the sub spindle. And right now I have kind of everything turned on for the visual. And so that's kind of the first step. And then when you get into your turning operations, you're going to see when I go into any main spindle operation and I go to parameters, what's really a good habit here is to, when you start working with two spindles, is make sure that kind of the first thing you look at is this lower left corner and that you have the right axis combination selected. It's very easy because it'll default to this. When you go into your axis combinations, when you're starting with a new file, you're going to have left upper, and then your post processor will put the right upper axis combination here, but nothing will really be set for this in a new file. And so what's required is that you select right upper and then you create a new tool plane. And when you create a new tool plane here, you'll see that it says left upper right. And then what you want to do when you create that is you're going to set your work offset to a 1. And what that's going to do is that's going to set up a G55. And then you're going to put your symbolic distance to where G55 is at here. So I've got a work offset of 1, which will trigger a G55 whenever I call up and use lathe upper right. So in my example, I did this earlier and I just renamed that to sub. So I know that when I look at the axis combinations, I just look for sub, and that's automatically going to give me the spacing and the work offset. Okay. So this is something you have to do when you start a new session in Mastercam. So I'm going to cancel out of this. So you'll see all of my main spindle ops are all set to left upper, which is just the default. You don't have to set that. That's already set for you. You'll see that after my POCO ops down here in these sub ops, if you were to open one of these up, you're going to see that I have my axis combo set to right upper. And that has this spindle origin all set with the work offset of 1, which is G55.
And then,
so that's how we're getting the two. Yeah,
oh, and just to kind of talk about that, sometimes I find with individuals, they'll go to work on the sub spindle, and when they start their work, because their tools default to that upper left axis combination, they're not able to get their lathe tool paths to look correct on the sub. And so that's where it's always good to check that axis combination first when you're building your new lathe operations on the sub, just to make sure that you are in the workflow of making sure that you're picking the correct axis combination. Mastercam doesn't know what side you're going to be working on. So that's something you need to keep in mind for subs.
Yes. So any questions coming in on that? Because that is one of the trickier parts here. Once you get over this hurdle, you're probably going to be in pretty good position to start working with POCO and getting operations to be in the right position when you get them set up.
No questions currently. You're always welcome to ask questions in chat.
Awesome.
I think we can go ahead and continue on.
Okay. All right. So that's a little bit on axis combos. So I did have a note here to talk about margins in stock, but I'm thinking that's probably most are familiar with that, but let's just touch on it real quick just to make sure that when you're in your stock setup and properties, in my example here, I am using just the standard kind of stock definition, make from 2 points, keyed in, you know, the exact OD of the stock that I want to order. And then the length is the actual length of the part. And the position along Z-axis is just set to Z0. And then I'm using a right margin to give me my 30 thousandths of cleanup for my face operation. You can simply shift the Z position of the stock 30 thousandths and not use that right margin. And I've seen that done both ways. So Jeff, what are your thoughts on that?
I am one of the.
Do you typically use the margin, or do you?
No, I'm naughty. I've always had the margins off, and I've repositioned my Z, the 30 thousandths, but both are effectively
right.
the same. The difference would be, I believe, the margin bakes in for your like the length of part that you put in. You could leave that the same, and then when you add the margin in, it maths that out for you. Versus if you push your Z face out, you then physically need to account that in for your part length as well. So
right. I did hear, I think last week, that one of the advantages of using the position along axis and just shifting the 30 thousandths there is that if you're using predefined stock blanks and you're putting in the length of the blank, that's more accurate, right? Because that's literally what you're doing, is you're shifting that. So, but that's where the margins are. You have to turn them on. Notice that I have lots of left margins so that, you know, when we do the pull for the pick off, that it has material to clamp back down on once, you know. So it's kind of like an arbitrary, plenty of material there so that when POCO happens, you know, there's something there for it to clamp onto, sort of simulating the idea of a bar feeder, you know, there.
And along those lines, if you did not have that there, if you didn't have the bar being long enough, you will get an error that, you know, something like left chuck, no stock to clamp or something like that. And that's what's going on. It's just missing the, because it is looking at the boundary of the stock representation when it grabs. And if that doesn't exist, if it's been pulled out too far, you'll get an error.
Yeah. Yes. So I did have a note to talk a little bit about jaws, but I think we have really good videos on the jaw setup itself. Let's just see if anybody has a question, or if you want to spend some time talking about jaw setup. We can let people pipe in there in the chat. Otherwise, we'll skip past that.
No questions so far.
Okay. I was kind of guessing that might be the case. Okay, so we kind of went through axis combinations, I think fairly thoroughly there.
Maybe show where in mill operations we would access the axis combinations, because it's in a different location.
Yeah, I think this is a good time to talk about that. So when you're into a milling operation, so let's start with my first mill operation here. It's going to default to left upper, but you'll see that in milling ops, it's down here under axis control, axis combination, left upper or right upper. And so this is just simply a selector here. You need to make sure that when you start doing milling operations for subspindle, that you have right upper selected. So it's just a quick toggle between left or right here under axis control. Again, you could get some fairly erratic results if you didn't have that selected. For those sub-spindle cross or face milling operations, you need to make that selection here. So again, just kind of reiterate, it looks quite a bit different than when you're in a lathe operation. It's a little more in your face in the parameters of lathe operation, being that it's right down here in the lower left. Okay.
Yeah, and then
so
I guess an indication for people when they post out their code, let's say you had it on the wrong axis combination, you would see those ops that you were expecting as a sub op would output as G54 as opposed to G55. And then you would have some silly Z height, 15 inches instead of where you would expect it to be on the part. So that's combination is incorrect.
Right. So this leads into a quick concept and discussion on building out a template. And so there's a fair amount of setup that goes into kind of getting everything set in a file like this. And this particular example is, we use this part all the time for testing and for training. And so with everything set, I've got view sheets that are set to show, what the base machine view is. Your C0 cross plane is set, C90, C180, C270. A couple of extra views just mostly for graphics. Face C0, C0 cross sub, C0 face sub. And so taking the time to, build out these view sheets, again, this isn't training on view sheets, but what that's doing is that's toggling all of these plane settings, and I have all these planes built in. If I were to take this file now that it's fully programmed and just remove the part from both the left and right spindle part from the file, and the POCO ops can be stripped out, because those kind of need to be recreated when you start to build out a new file. And then you save that template. Well, I already have my distance between spindles set. I have all of these milling planes defined, ready to go. And then all you need to do is merge in the next lathe part, adjust your stock, adjust your chuck jaws, maybe even leave these turning and milling ops in here because you might be using those. They'll all have red X's because they're not connected to anything. But you can see the benefit there, right, Jeff? There's a lot of settings that we just put in place that we could reuse for the next lathe project.
Yeah, anytime you start a new project, you're kind of going through the same motions of establishing your planes, because that's a manual process for MP when you're going to be using your milling operations. We'll touch on that, on how to set up those planes, but it is a manual task. And so if you can create a template where those planes have already been set, hey, that's 15 minutes worth of work you've just saved.
That's great. So I'm going to talk about building the milling planes now. So we're looking down from Mastercam's world top view, and visualize this as sitting on a lathe with two spindles, so left and right, main and sub. And this top plane right here that's in plane with Mastercam's top view is not your C0 cross plane. So that I'm going to kind of demonstrate by sort of just using a motion controller to roll this around. So we can kind of track and follow and look at this. So look at my view gnomon here in world. You're going to see the Z-axis is up. Don't think lathe coordinates when you're looking at this, because this is world coordinates. And if we were to come around and look at the face of the part here and go around to this side, this plane right here, to mill this plane is your C0 cross plane. And all of the Mastercam posts, be it MP or dot machine, this is always C0. And the way to kind of look at that is when you look at your face C0 plane like this, think about polar coordinates. Your 3 o'clock position is always C0. So from face milling, this position right here would be C0. This would be C90. This is C180, and this is C270. Now, some machines in post-processing, this is C0, C90, C180, C270. That makes it fun. Well, the post-processor takes care of that for us, right? So if their view system and the way they define the C-axis rotation, if it's going the other way, we can just take care of that in the post, so you don't have to think about those numbers. But from Mastercam standpoint and programming, this is your C0 cross view. So we could figure out what plane that is in Mastercam, looking in the planes menu, and figure out, well, that's probably Mastercam's back view, and go to the G view and click, and look at the part that way to see if that's correct. But another way to handle that is, let's go back to my face view, and I'm going to just rotate this around. We could just create a dynamic plane by clicking on this, dragging it up here. Oops, let me see if this is working. Okay, dragging it up here and snap it onto this plane, and just drop it onto that flat face. And then you need to make sure that X positive points towards the main spindle. All right, so that's very critical. That plane is now in alignment with this face. And then kind of the final step is to move to WCS origin. When you hit equals, that's going to move the origin of that plane to the finished face of the part, and then give that a name. So we'll call this C0 cross, like that. All right, and so then setting your work offset, this should be set to 0 for my main spindle C0 cross. When you start creating these planes, you can start copying planes and modifying them. So for example, I'm going to call this C0 cross 1, and then it might even be faster to take that particular plane and duplicate it. And let's say I'm creating, let's rename this to C90 cross. Right now it's a duplicate of that other plane, but I can right click and edit, and then just rotate that 90 degrees. So your Z would be pointed up. Whoops, let me catch this again here. I got to get in a little closer. So make sure you get a hold of this and just rotate this 90 degrees. I've got some lag here on my display. All right, and so then you would change this to C90 cross. So that's already got the proper work offset. You can use that technique of copy or duplicate views and then edit the rotation to get all your different planes. If you're working from a template, all of your, maybe in your template file, you already have all of your basic C rotations. Maybe you have C0, 45, 90, kind of all the way around the part, and that's already in your template. So you don't have to do anything. You don't have to create these. They're all preset for you. You've got your subspindle view, you've got your face view, and as you start to build these up and accumulate them, you can do it that way. There is a utility in Mastercam Lathe, but I'm going to show you this. It's been here for many, many years, and it's just called C View. So this is an old utility that you can click this, and you can just simply set this to cross and perpendicular, and then select a line element, and it will give you the rotation. Okay, so this is C0, and it knows and understands the kinematics of the machine, and that particular plane would be a C-axis rotation. And when you hit the check mark, it's going to create a new plane for you. But by working off of a solid model, it has to have a line there. So by the time you create the line, go into the C View utility. I think it's more clicks than just clicking on a face moving it to the origin and giving it a name. It's maybe a toss-up in terms of
Yeah,
workflow.
and just to reiterate,
but that's what that.
For Tim here, when he means by line element, it's wireframe geometry, because that is an older utility.
Right.
So that's why Tim clicked on the wireframe he had on the solid.
Yeah, but it is another option. And so if I go to wireframe and let's create curve on one edge, and let's pick this this flat up here, and let's put the line there, and then go back into turning, go back to C view, and click, make sure this is set to cross perpendicular, and then select the line here. See, you're going to get the C90 there, right? It has this funny little display feature too, which will put a tool in at the origin in that orientation, just so you can see, yeah, that looks like the right plane, right? It's perpendicular to that line and already set to the origin for you. And then, when you press enter to continue and you hit the OK button, it's going to build that additional plane and stick it into the list there for you. So you can do it by C view. I think that's the maybe a much older way of doing it compared to just using dynamic planes and clicking on a face. But it is the precursor to the tool plane functionality that's built into the mill turn. So if you go to dot machine, you're going to get an entirely different tool plane functionality where it will automatically build tool planes based on the tool path. So it has the ability to derive the tool plane from the tool path itself, and you don't have to create anything. And it automatically sets the origin, sets the tool plane, and sets everything up for you. There's also a feature when you're in the dot machine environment that lets you manually create tool planes that's like this, but it's much simpler. You just click on a solid face and it creates it. So a little bit on that subject. Let's see if anybody pops in with any questions about building planes for milling for mill and lathe. Give them a minute there to see what happens.
So far, we've no questions, Your Honor. No further questions.
Okay. All right. We'll keep moving along here then. All right. So I think we covered everything there in the planes. Easiest way to create dynamic versus CV utility. And then we talked about making a template to save time. Looking at the planes, this note here is remember you are the machine when you're thinking about the definition of the planes. When you're building cross milling planes, I always like to think of it like I'm looking through the back of the machine. I'm standing behind the machine and I'm looking at that milling plane in a standard XYZ orientation. That's why X plus points towards this spindle. And that when you get to your cross milling planes for subspindle, those are not flipped. They're just translated down to where the subspindle is at. So, okay, so I think that covers that. And let's talk about POCO now. So in building a POCO operation, first of all, you have to have a post processor that is built specifically for your machine. You're not going to get good POCO out of any kind of a generic. If you know how to get around in the MP post language, you could take a generic and you could add good POCO to it, but that's a fair challenge. So buying a custom MP type post that fully supports POCO, you're a fair chunk of your way into buying a dot machine environment. So just take that into consideration. Because if you end up buying a dot machine, you may have wasted your investment in the MP type post because you wouldn't be using it. You'd be using a dot machine instead. So take that into consideration. Won't get into pricing because there's a variety of possibilities there. But when you're dealing with POCO, build out the typical setup is you build out your main spindle operations and you get ready to develop the POCO. You build your POCO, it's automatically going to, from going up here to part handling and clicking on your pick off cutoff after your main spindle operations are done, you tell it you're going to do pick off, bar, pull, cutoff if that's the case. If it's just pick off and cut off, if you're using slugs to just a pick off, so you've got your different styles of operations here. And then making that selection, selecting the geometry, telling it to translate. We won't get into all the training for POCO, but these settings all need to be set, your length of your finished part, and the pick off Z coordinate is where you want to, the subspindle chuck jaw face and where that aligns to the part in the main spindle is that coordinate. Your cutoff size, the X coordinate can come from the stock, and then how much face stock you want to end up with afterwards. So after you process this, what you end up with is this folder of these operations. So for this particular post processor, this triggers, I think 11 different operations, and these are auto-generated and dropped into this folder for you. So you're 3/4 of the way there. You've got the POCO ops in place, but in these operations, there are settings that you need to set. And if you open up a chuck operation, so I'm going to take the first chuck op here, and you'll see that in custom parameters, there's these settings here. So you're not going to get good POCO unless you know these settings and you know what to set these to. And these are very machine specific type settings. So ideally, your post processor for MP with POCO comes with an instruction sheet like this. So this tells you at these pick off, pull, cut off operations, what these settings are and what they do and how to set them. And so we don't need to get into all the details for this particular machine, but it'd be very difficult to get good results from a POCO operation or set of operations without setting these settings. So these include things like your pre-position, do you want a rapid to clearance? And then do you want to feed onto the part? Do you want to use a torque skip if you're going up against a flange? How far before the flange do you want to activate that and slow down as you begin to touch that face? Your air control spindle, if you're flushing. So all of those types of settings are in this document. Now, if you don't have this document, you want to get back with the developer for that post and ask for those. Sometimes they're in the header of the post processor itself. I've seen these instructions just embedded in the PST file itself, but typically it should be a PDF that goes along with the post.
Yeah, and kind of
so if you don't have that,
and elaborate on that. This is just because machines are different from machine to machine, and inside Mastercam, those part handling operations are essentially an overview of how it will work on all machines. But then these custom parameters then need to be set specifically tuned to that machine's GRM codes or what options are available. So it's machine specific, and that's why the post developer will have a document specific to that post.
And with a little bit of custom work, you can get these to default. So again, that's post work to get these to default to your common settings, but there's still going to be variables. So just remember that once you build POCO, you're not done. You need to go in and where it's needed, this move to clearance is going to default to, I think this one defaults to 0.5, but maybe you want to make that like 0.1. You want it to wrap it up a little closer. And then the next operation is feeding onto the part. And when you feed onto the part, you want to maybe have a high feed rate so it's not taking too long to get there. So that's dropping the POCO operations into place, making adjustments there. and then knowing what those adjustments or settings should be. So if you're struggling with POCO, those are some things we can also help with. We have some training materials available for that. And again, making sure that you have the proper settings for your MP type post. You get into a dot machine environment, you don't have to worry about that. That stuff is put in there for you. You can adjust it, but it's all placed in there for you because Mastercam already knows the details about that machine coming from that machine environment. Okay, so I think that's about the tail end of this presentation here. Let's take a look.
I think the other thing we wanted to talk about was single stream versus multi-stream and how you kind of layer the POCO group into Mastercam. And typically during single stream machines like we're demoing right now, the way Mastercam is layered, where we have a toolpath group for the main spindle, then your POCO operation, then your sub spindle is typically how you would have this set up. And then if we had a multi-stream machine, say we wanted to, we had 2 turrets and we could do work on the main and sub at the same time, you would then want to rearrange your POCO operation to come at the end of the program. So when you post out your code, you're doing work on both of the spindles at the same time, and then you complete with your POCO operation. And so that's where Tim, right? We program initially like it's a single stream machine. And then when we're ready to post code, we can then move the POCO operation after the sub.
You drag the POCO operations down and you drop them below the sub and move that there, and then regenerate everything. And then, so like for Swiss applications, they're all done that way, right from the very beginning. You do your programming this way, but then you're taking the POCO and making that at the very end. So when you get training for a Mastercam MP Swiss post, that's one of the first things that we do in the training, is to get the users to understand. In fact, that's what John's working on today, is a Swiss install. So that rearranging this can be done, and then that gives you the ability to synchronize and make things happen at the same time, with 2 different turrets. So short run, a few parts, run all your main spindle ops, do your POCO, run your sub spindle ops. But then when you go into production, that may not be at all what you want to have happening, right? So that can be rearranged. And any other comments on that you can think of?
Not for me, but that's because I'm a single stream kind of lathe guy. So I don't have much experience with multi-stream lathes, unfortunately.
Well, it's ops. Okay, let's go back here. Then I wanted to make a quick mention, if anybody's working in lathe and they had been experiencing any problems with turn profiles, that's been fixed in Mastercam 2023 Update 4. It had to do with changes to the Parasolids kernel, so the solid modeling kernel. So you now have the ability to do live turn profile right off solid models. And so that has been fixed. So if you had given up on the turn profile from a solid model, load Update 4 and give it a try, because it's working great.
Yeah, and some people may have found that it was working, and I found half the time it did seem to work just fine with solid models, and sometimes there were issues, and you'd have to go back to wire profile. That Update 4, did that come out this week? I think. Yeah, it was Monday. It was Monday this week that Update 4 had come out. So if you have not updated your Mastercam, be sure to do that. That's through the File tab of Mastercam, then on to Help. There's a Check for Update button. I do want to make an announcement, though. Some people who have been early adopters have not been getting their automatic update services working. There was an initial bug with the release of 2023. So if you're still on Update 0, that's what's going on. You need to manually log into my.mastercam.com and go to the downloads page and get the patch updaters there. That was fixed with update 1 of Mastercam. So if people downloaded 2023 after, I think, the month of July, they were getting the correct update where the automatic updates were working. But those of you who got Mastercam when it was initially released, which was between May 31st of last year through like July 7th, you have update 0. So you need to do that manual update. But we are on update 4, and it has resolved that solid turn profile issue.